Hi, my name is Sydney Cumby, and this is my presentation on the PHYS2212 Lab 1 charge tapes. In this presentation, I will be explaining the experiment in which the system is the U-tape and the surrounding is the base tapes, and some fundamental principles in physics, my observed results, including models, observations, and collected data and calculations. Then I will show my computational model, to which I completed on GlowScript to help in my experiment, and finally answer some additional questions. The purpose of this experiment was to find the amount of excess charge on objects using pieces of clear tape. Another purpose was to use Newton's second and third laws along with Coulomb's law to determine the physical properties of a charge. This resulted in the U-tapes repelling each other due to the charges having the same sign. Whether that then both be positive or negative, I didn't know until further in the experiment, which I found out that the tape was positive because of its attraction to the negatively charged pin. I was able to calculate the charge of tape, which was 1.7 times 10 to the negative 8 coulombs, and the number of excess electrons, which was 7.29 times 10 to the 10 electrons. A few key fundamental principles to understand to use within the experiment are Coulomb's law, which is F is equal to K, which is the constant, multiplied by Q1 and Q2, which are the charges, and then R squared, which is the distance between the two particles squared. The electric field, the force on a charged object, and the force of gravity on an object all have the equations shown. In the image that I have shown, the like charges repel and the opposite charges attract, which is also a key understanding needed to find the results of this experiment. The experiment is done in 3 sections. The first section was to charge the tape, which was done by putting a piece of tape 0.2 meters long on a table and then layering the U-tape on top. Then I would rip the U-tape off the base tape in order to charge by U-tape. Then I had to test the 2 charges, which I used by holding my hand near the tape, which attracted to my hand. Then I held 2 U-tapes together, which repelled. Then a negatively charged object, which was the pin, to the U-tape, and it attracted as well. After observing the attractions and results of testing my charges, I could calculate the excess charge by attaching 1 U-tape to 2 bases, then holding a second U-tape parallel to the first and measuring the distance of the flow upward. This experiment allowed me to observe that the 2 U-tapes repelled each other, showing that they were like charged. When the U-tape was put next to a negatively charged pin, it attracted to it, which showed that the U-tape was positively charged. The assumptions that I made within the experiment were that the U-tape was acting as a point charge. Then, the tape's charge was at the center of the strip of the tape. And finally, both tape pieces have equal and same distribution of charges along the strip. Some data I collected within the experiment was the length of the tape, which was 0.2 meters, the width of the tape was 0.02 meters, and then the distance floating upward was 0.025 meters, which I measured after the float. Using this data, I could calculate the surface area and number of atoms. Then, using Coulomb's law, I could calculate the charge of the tape, which was 1.7 times 10 to the negative 8 coulombs, and the number of excess electrons, which was 7.29 times 10 to the 10 electrons. The computational model I used was used creating the data points I collected in the code I created in GlowScript, which gave me the calculations of the charge of the tape, which as shown was the exact same as what I calculated earlier. In the model, the blue point is representative of the U-tape on top, in which the red point is representative of the U-tape on the bottom. The yellow arrow upward is representative of the electric field which was caused by the experiment. To conclude this experiment and presentation, I have a few additional questions to answer. First, what if the electrons had been a positive charge and the protons would have been a negative charge? What would have changed about the observations you have made in your tapes, charged objects? So even if the charges would have been changed on the electrons and protons, the tape would have still repelled. This is because both of the tapes would still have the same like charge. Second, why is it important to handle the charged tapes as little as possible? What happens when the charged tapes come in contact with other objects like your hands? When touching the tape, the electrons transfer between your hands and the tape, affecting the flow of the tape. Therefore, the more that the charged tape comes in contact with other objects, the less of the electrons that will be on the affected tape.